Thanks, Wayne. So I'm gonna do a bit of a walk through SmartSat CRC as well. I hope that's okay.
No worries.
There's been an interesting sort of pivot in SmartSat CRC just recently, and so I thought I would sort of also make sure that folks are across that pivot, and then I think having folks like Eva here as well, pretty amazing development. So I think we can talk a little bit about some of that stuff as well. So I'll share my screen briefly and sort of step through a few slides, hopefully not death by PowerPoint, but some of these you've seen before, I'm sure you know about SmartSat CRC. They managed to scoop up a whole lot of different organizations. Some of these even paying some money. And what's kind of unique about the CRC is, in fact, unlike other collaborative research centers where there's a lot of industry who are customers in the CRC, a lot of these folks are actually suppliers to government. And so it's quite a different kind of industry CRC setup from, for example, the Food Agility CRC or some of the other CRCs that I've been involved in before, which has given it some interesting, I suppose I'd say, extra arms and legs in terms of saying, right, well, we can actually develop industry. We can also vary the rules a little bit on how much different companies have to contribute and so on. So it has this vision now of being a powerful R&D engine for the Australian space industry. One of the things that certainly folks from overseas realize is that our current space agency is actually not an R&D space agency, right? It's not actually an agency that is doing what NASA does or what ESA does or what CNES does or what some of these other agencies do yet. It is not. It is mainly a strategy, regulatory agency, but it doesn't really stretch that far down into development other than sort of like the grants programs and so forth. And also those grants programs aren't pure grants. In majority of them are also matching funds programs inside the Department of Industry. So SmartSat CRC has actually ended up playing this role of starting this process of doing R&D. And also, of course, supporting the agency, supporting its program, supporting its strategic execution. And so this is the aspiration, effectively, of SmartSat CRC. And I've been able to sort of, be involved in them now for a couple of years. And that, it is exactly what it says on the tin. People care very deeply about trying to build industry and getting industry involved in these projects. And connecting universities and industry partners. So it's been pretty cool, actually, and I've been pretty impressed. But I'll talk a little bit more about the pivot that's also coming up that's recently been announced, which is, I think, pretty exciting. And so it's got 3 core programs. That's my dinner that's just arrived. There we go. We've got 3 core programs. Advanced comms. Turns out Australia has a lot of great knowledge, of course, around optical communications, around long range RF. We have massive heritage in radio astronomy, and all sorts of different bits of expertise and amazing people. So comms was a natural one. And of course, we've got 2 scale-ups now doing IoT in this country. And people like Inmarsat starting to kick around, with all sorts of different, even bigger bandwidth IoT type products. So we've become a bit of a testbed country for IoT. Second one, AI in space. Next generation cameras. I'm sort of pretty excited about this one because I think there's lots and lots of possibilities in terms of rethinking how satellite buses are designed, opening them up, making them much more plug and play, abstracting more and more and more of what's actually still, in many cases, bespoke hardware. And then the third one, of course, next generation EO. So that's very much about downstream and cutting across these 3 horizontals: artificial intelligence, cybersecurity, and resilience and governance. And so these are sort of guided the CRC and they have special interest groups, or rather special advisory groups around each one of these. And some of you I know are members of those. So in the first year, actually approved a lot of projects, recruited some senior folks, and started to do some international work. I think the I actually helped to run a skills gap analysis as well as an impact of COVID project. And we've done a whole series of webinars to help the agency, talk about different components of their products, because we can get into lots of different places. And we've invited a lot of pretty cool speakers to come and visit. So, the things that you would expect us to do. We've also set up, as I said, these end user advisory boards. We've started nodes, state nodes, and I'm going to talk a little bit about the New South Wales state node in a second. I've also been very privileged to be asked to volunteer and in some cases get a bit, kind of get paid for some of that work to help set up a space startup cluster company, Aurora. Many of you may remember back in the day, I think 2014, with Ivor Cairns and Jason Held and Brian Lim and Andrew Dempster, we set up Delta V, and we actually achieved a whole lot of different things in the ecosystem on the smell of an oily rag. So Aurora, in many ways, is a slightly better funded, with the backing of SmartSat CRC, startup cluster for space companies. It's a separate company. It's actually a full subsidiary of SmartSat CRC. And it's an example of what I was talking about before, where the CRC has actually realized, okay, we really do want to lift these younger companies and create a ladder, effectively a TRL ladder, an investment readiness, an IRL ladder, and a commercial readiness, CRL ladder. We want to create ladders for these startup companies. And in what we're learning is that in deep tech generally, and in space specifically, small companies need partners. They can't really sell to customers until, especially upstream space hardware companies, they can't really sell directly to customers until they've flown, or until they've really been able to demonstrate that their hardware works in situ. And to do that, they really need all sorts of programs like SmartSat CRC, of course, like the New South Wales government's Waratah seed program. And that is starting to bring primes, that is starting to bring bigger SMEs into the fold and start to say, okay, well, you've got some great technology, you maybe don't know as much about business, we'll enfold you, we'll help you, we'll guide you, we'll mentor you, and we'll also do contract bids with you with our big cap table and your kind of hustle. So that's something that we're hoping to sort of see more of from Aurora. And then we've also part of this, being headquartered in Lot 14, SmartSat CRC does get quite close to South Australian government initiatives. So the SA-SAT-1 satellite mission announced by the Premier of South Australia is an example of where, small state, concentrated ecosystem, they can make those sorts of decisions and move. So that's an exciting project which SmartSat's also running on behalf of the state. And so you'll see how SmartSat CRC is kind of almost, in one sense, in the South Australian sense, it's almost acting a little bit like a space agency in a sense. But with the New South Wales work that we're doing, we're hoping to extend that, of course, around Australia as a model. So I went the wrong way. So we've also got a new chief research officer who has literally come out of lockdown this weekend and moved back with his parents, himself, his wife, who was also a JPL scientist, and their 2 kids. Have just moved full-time back to Australia from JPL. And so Carl is going to be based here in Sydney. In fact, he's going to be based working out of the National Space Startups Hub at Cicada down in Everleigh / Redfern. So, stone's throw from where Eva's labs are, where UTS is, where the whole New South Wales Tech Lab is. And I've really enjoyed working with Carl. He's very energetic, he's very knowledgeable, he's very well linked up. So he's going to be a great resource for New South Wales in particular, and Australia more generally. He's very passionate, he's very enthusiastic. He's a good bloke. And I'm looking forward to meeting his wife and partner as well, who's apparently equally senior, if not potentially more senior JPL scientist, who's taking on Australia for the first time. So look out. I think Wayne, Carl would be delighted to appear at a future evening. You should book him soon. He'd be a great speaker and tell some great stories. And I do believe his work is also in the current Mars mission. Sorry, I should say the rover mission that's currently running. I believe is also part of that, as well as some of his work is being around the moons of Saturn, and I think he's an expert on Titan in particular, if I'm not mistaken. Anyway, he'll be able to correct me if I'm incorrect, but I know he's very enthusiastic about planetary dynamics and guidance, navigation, and control. So New South Wales Node. So we've been operating now since March. We have this structure in New South Wales. It's co-funded by New South Wales government, hence the logo in my background and on the right-hand side there. New South Wales Chief Scientist's Office, in fact, and also the new New South Wales Department of, I think it's called the Department of Innovation. I should know that since they're my boss. Anyway, you would, I'm sure, be familiar with Bryony and Paul Hepplewhite, Bryony Sturgis and Paul Hepplewhite, who are in the New South Wales Space Office. They've moved from Treasury over to the Department of Innovation. So they're in the Node Steering Committee, among with a number of other folks, including Stefan from the new Space Research Network, which has also recently been funded. So, so we've got these programs, essentially these 4 programs: Space R&D Partnering, which is specifically demonstrators, and 2/3 of the cost of those demonstrators, up to 100K, are funded. So in other words, a industry partner or an industry and university partnership, or even a consortium, they can come in, they put in 1/3 of the budget, and then the node funds 2/3 of it, up to 100K right now. We're thinking in future rounds we might push that up to 250K. So we're sort of starting small, but we're actually thinking we're going to push it in terms of value higher. We've got a mobility program, which is talent from universities into industry and vice versa, up to 6 months of full-time employment. So it could be like a postdoc, or it could be a middle manager in a company, go into each other's organizations, and that's 100% funded. And there's also a third program, which is access to infrastructure. It turns out, as many of you would know, my gosh, there's some amazing kit lying around in New South Wales. Incredible anechoic test chambers, shake tables, clean and dirty vac chambers, you name it, we've got it lying around. We've got a nuclear reactor, we've got all sorts of great stuff sitting here in New South Wales. And so what we're hoping is that industry can essentially identify with both our efforts and also the Space Research Network efforts, Defence Innovation Network efforts, and New South Wales Smart Sensing Network efforts, all these different networks that have been funded and co-funded out of the Chief Scientists and Engineers Office, Hugh Durrant-White's office. They can identify a piece of kit, the person who's going to be able to operate for them, and then we will pay for access to that. All right, so that's the New South Wales Node. And then finally, networking and events. So we not only me sort of appearing at events like this, but also we have a model for design workshops where we essentially, we ran one of these recently at the CubeSat workshop, where we ask the academic and research teams to interview industry about their problems. And it does 2 things. It showcases how smart our researchers and our scientists and engineers in universities are, because they ask really smart questions. And it also, and it demonstrates their capability. And it also intrigues industry, because they realize that, industry's problems are of interest. And when they have to explain their problems, they realize that, universities and research folks can help. So it's about creating those relationships. And, people often see, they think of research folks as in an ivory tower, safe and secure. And as we know, that is totally not true. Researchers are more often folks they're like sole traders within a trading system inside the university. So they're very entrepreneurial quite often. And so what we're also showing to industry is actually you have more in common with these folks than you think, and you have more to gain than you think. And so these are the programs that we're doing in New South Wales. And then recently we've done a real site visit, and we've done a virtual site visit. I'll just flip to that real quick, and I might even dig out a video for you and see if I can show that. So we did a visit to AquaWatch maker, I should say, and I'll talk a little bit about that in person, and also to GPC Electronics. And I have to say, these have been an absolute highlight so far of the work that I've been able to do so far. Oh, I should mention, we've had five successful EOIs. We're about to announce them. In total value, they're about $480,000 of spend. We haven't announced them yet because we want Minister Ayres to make a big splash. So hopefully that's going to happen within the next week. And then he's also going to announce the next round of our EOIs. But anyway, so we've had five projects funded under this Space R&D partnering program, all of them demonstrator projects, and all of them by startup companies working with universities. So it's pretty exciting. So the AquaWatchmaker visit, terrible diversity in that picture, I'm afraid. So we recognize that we need to certainly get representation. We were age diverse, which is good. You know, I was there, so representing the older people, but certainly we didn't have any females. And so we're going to work a little bit harder on that and see if we can work in timing, schedule, different channels, and so forth. But what was extraordinary about that trip was discovering that in Brookvale, there is a little slice of Switzerland. And I'll be more precise, there are machines there that exist nowhere else in the world except Switzerland and Brookvale. That's it. There's none in Japan, there's none in America. That's the only place. They also have a machine, they have one machine there that I think there's only one or two others in the world outside of Japan. And they've also got one in Brookvale. So they've done an extraordinary job. Nicholas Hacko, who's the son of the original AquaWatchmaker, actually spent a fair bit of time in this specific part of Swiss Germany. And when you spend time with him, you realize he's really been imbricated with this quite ancient love of precision engineering and the craft that represents. And so I'm hoping that we could do another visit to Hacko, and they've actually rebranded themselves as a precision machining company. They have made watches, and they're quite extraordinary things, and they sold out. They're about $10,000 each, but they sold out almost straight away the minute they made them. But in fact, they're realizing that there's a lot more to be done in precision engineering. So we have an amazing time on that trip. And I recommend if we get the chance, perhaps next year, to do another trip, come along, because you get this sort of taste of this 400-500 years of precision watchmaking and development of micron scale fabrication that they have managed to crystallize into this facility in Brookvale, and it's quite extraordinary. The other visit we did was to GPC Electronics in Penrith, and GPC was actually again, it was a pretty exciting trip because GPC as a company is a precision manufacturer that does work for medical, defense, it does agriculture, it has all the different kind of DISP accreditations, aerospace accreditations, etc. And the founder or the managing director of that company has become quite passionate about space. I'll give you a little quick, I'm just going to stop sharing this screen, and I'm just going to show you just a little bit of video real quick. I'll just queue it up about GPC. Let's see if I can make this work, and click that little button that says share sound. Yeah, great. And I'll share this. Can you see that okay? This is actually a video. So basically they're a contract manufacturer. They manage they manage electronics and test, and they're also interested in like new short projects. And they've had a deep dive into small satellites and actually realized they think they can make them. They think they can make satellite buses up to this 150, 250 class without too much trouble, is the way that they put it. So I'll let you
go through this.
I'll let you listen in.
Use it there. So this is obviously in Penrith. These are pick and place machines, and you'll see them in a little while. This is looking internally a bit so you can see what happens. And these machines are capable of placing per box about 50,000 parts an hour. And we have 3 of those boxes in a row and 3 lines like that doing that. Everything we process goes through AOI, automatic optical inspection, which scans the board against CAD files and verified images, and then identifies any problems we might have in the processes, which we can feed back into our process. This is a radial insertion machine. That's for parts with leads on them, and feeds from the back and load components. It cuts and clinches the leads on the bottom as well. Some of the processes still have to be hand fitted. So we have a slide line where people hand fit some of the odd shaped components, which are through hole. And that ends up going through a wave soldering process after that. Some of the parts we have are connectors and things which can't go through, a lot of parts can't go through wave soldering. So we need to do some what's called selective soldering. So this is like a robot arm, which actually, where we preheat the board, we add the fluxes, spray on in the location we need, and then we just solder it on a tiny wave for the connector, whatever it is. These are some other robots we use. And what we find is that these are very accurate and highly reproducible. And the advantage of this is both in terms of throughput, but also in terms of reliability and throughput on some of these processes. And as you can see, it solders as.
So they took us for a tour. We actually walked through the factory.
That's right.
And they showed us
service mount placement machines.
All these different machines doing, this is X-ray, X-raying boards so that you can see the quality of solders. They had all sorts of different interesting things going on, all sorts of different products. And they also very carefully demonstrated how, you know, they very carefully didn't show anybody's logos, but they sort of demonstrated the capabilities that exist in New South Wales already. And so a lot of folks, and we had a few folks actually turn up from overseas to listen in to this, and they were pretty blown away. So the fact that we actually have about three or four of these companies in Sydney area alone, and GPC is one of the particular ones that's leaned in to the space arena. So I have a video that I can share of that whole trip if you would like to do a deep dive, and I can share that to Wayne and he can share it around later. So fundamentally, I think that sort of New South Wales capability of precision electronics, also large scale manufacturer, which we're also going to go and do some site visits with some of the folks like Roma Engineering and Omni Tanker, who are doing, you know, large scale 3D printing or large scale carbon fiber winding. There's a lot of that happening in Sydney, as well as in Newcastle, as well as in Wollongong. There's some incredible capabilities. And what we've discovered really in this journey that we've had so far is that it's actually, the talent is all here. The capability technically is all here. The systems engineering knowledge is all here. It just needs folks to pull it together. And there are a couple of SpaceX alumni kicking around in Sydney. Steve Romar is another great guy, Wayne, that you should bring in and have a presentation from. He's an ex-SpaceX engineer. And if you ask him, hey, listen, how hard would it be for us to build a Falcon 9 in Western Sydney only, or even a Starship and a super heavy booster in the Sydney or New South Wales region? How hard would that be for you? He doesn't hesitate. He doesn't blink. He's like, we could totally do it. It's not that difficult. We have all the capabilities that we need here. We just need to find a way to draw it, you know, together. And that's I think being one of the very interesting things that SpaceX has identified, is that COTS, commercial off the shelf, and also a lot of the existing capabilities in automotive, aerospace, are in many cases much more extreme requirements than you need for space, with the exception of the cryogenic stuff. And so there's this view that New South Wales has these great capabilities. I'll just show a couple more. So I did foreshadow that I was going to talk a bit about the pivot that SmartSat CSE is underway. So the pivot is that the SmartSat CRC is now thinking about bigger projects. It's actually entering its 3rd year of operation. Its 3rd year operation is coming up. And so after having done a lot of small and medium-sized projects, they're now thinking about much bigger projects. So one of the big project ideas that we have is for a national civilian space mission, and essentially some kind of analog to the military mission JP9102, which is a very much a military procurement type mission, actually a much more open, agile, and sort of iterating learning mission, which can really move the state of the art ahead for Australia in these areas of communications, Earth observation, and PNT, position, navigation, and timing. And of course, also, these are going to be low Earth orbit satellites. And so there's global business model opportunities, we think. And so we're now thinking quite seriously, and I know that Canberra and other folks around the country are thinking very seriously about a civilian space mission, potentially even a public-private partnership mission, where we can have a series of releases of what are now classed as small satellites, under 300 kilogram class satellites, and iteratively grow our capability and as we build those out, and build a constellation of these smart satellites, make them software reprogrammable, software redefinable, and start to contribute to the data sources that we've benefited for so many years from other countries. You know, we rely very heavily on Landsat and Sentinel. We've made a small investment in Novastar. And of course, we beg, borrow, and steal all sorts of other data sets from all over the place. But there's this sense that if people decided to jack up the prices, or there was a political change, or even indeed we had some kind of denial of service from things like positioning from GPS satellites, the impact on our economy would be massive. If we had an impact on communications networks, if we had impact on weather satellites like the Imawari 2 satellites that we rely, you know, almost exclusively on for bomb type weather imagery and so on, then we would be up shit creek, you know, as a country. And so we are starting to think about, we need to really have this, you know, think very hard about critical infrastructure and national resilience. And also, I know that the defense intelligence folks are interested in assisting with this, because they certainly have a tasking issue right now. If our defense forces want to task one of the US spacecraft that they have share in, or indeed any of the other Five Eyes assets, well, we're, you know, friendly, nice, cuddly Australians, but we don't get to the head of the queue with tasking for our special forces or our F-35s or our indeed Navy or other fleet assets if there are partner assets where they own the spacecraft. That's an issue for us. So anyway, SmartSat CRC has definitely joined with Geosciences Australia, Space Industry Association Australia, that I'm chair of, actually. Would you believe, Wayne? I was roped into being chair now, in advocating for a national civilian space program where all sorts of technologies and capabilities can be demonstrated, but also new business models that, of course, global and reach. So that's definitely one of the parts of our pivot. And of course, another part is 3 big grand challenges, some of which you may have known: AquaWatch, Eye in the Sky, and the Indo-Pacific Connector across these 3 application areas. AquaWatch, a set of instruments that focus on freshwater in particular. That it turns out that there are almost no instruments that are currently in flight that are really focused on freshwater, on rivers and lakes. And in fact, there is no real movie of how water moves through Australia, the most arid continent, through all the different El Nino, La Nina phases and so forth, which is remarkable when you think about it. So putting AquaWatch type instruments onto a mission set like this is, of course, what people are thinking about, and doing that for the whole world. Eye in the Sky, very much about how do we get a much higher repeat rate for things like critical comms. And that ranges from everything from, 5G from space right through to much smaller infrared cameras that have a high repeat visit rate so we can get better situational awareness. Even things like using satellite relay so we can control beyond visual range drones and other sort of fire spotting equipment, everything you can imagine. Minderoo Foundation is somebody who is also looking very seriously at being partner with the federal government and to try to accelerate the development of some of these technologies to provide fundamentally, save lives, cut down the time between when an ignition event occurs and when we've done something about it. From, in some cases, many, many hours, fires that have an ignition event, nobody spots it, nobody sees it for many, many hours, and then it becomes an out of control wildfire. In so many cases, we could snuff those out if we just had a faster reactive capability that would involve, early warning from space, intervention, certainly survey, and potentially even intervention from larger drones and small aircraft before it actually gets to the point where we need to call out the Aurora Fire Service. And the final one there, the Indo-Pacific Interconnector, which is very much about cybersecurity. It's about linking our defense assets and doing, in many ways, a TDRS, a tactical data relay system for our Five Eyes partners and others, so that we have more resilience in our space network. The F-35 is an example of a data center in the sky, and that if it doesn't have connectivity, if it's cut off from being able to access all the other tactical assets in the battle space, then you're right back to a fighter which can only really do one thing, as opposed to the mission that we've set out for it, which is to be a hub for information, for weapons tasking, for remote control of all sorts of assets, including the Loyal Wingman program and other programs. So we need that connectivity piece. So SmartSat is starting to appoint folks, has appointed folks to lead these initiatives as major grand challenges and start to funnel some of the smaller project proposals into these streams, with a view to making some major, multi-million-dollar investments in each of these areas. And AquaWatch, I think, is personally, I think it's quite exciting. We have a huge sort of legacy of innovation in ocean activity, and we have lots of interesting research around GNSS reflectometry, around different kinds of instruments. So we want to have a coordinated series of research programs around all sorts of different ground truthing, as much as sensors in space. And if you can do great ground truthing, cal-val, calibration validation of this kind of data, a country like Australia can influence things globally. And in fact, I also reached out to the Red Cross to have a chat about this program, because it turns out the Red Cross is very interested in water as one of those flashpoints for global conflict. And so that there's ways that this kind of project could not just help with resource management, but also help with a world in conflict over limited resources, or resources that are in contention. You can just think about sub-Saharan Africa, Ethiopia, Egypt, that whole area there, and you can see areas where better data that's trusted could head off regional conflicts. And then Indo-Pacific Connector, very much around, okay, how do we get earlier warning? How do we get better connectivity? How do we deal with contested space? How do we deal with all sorts of different interconnects between our partners and defense, in the defense realm? So Five Eyes, the Quad, etc. And some of the kinds of instruments that we've been doing, that we've managed to draw together industry, government researchers and universities to do optical RF, to do free space comms. And I think this work has just begun. We've had some very interesting proposals from New South Wales, from Macquarie University, for things like angular momentum encoded laser beams, which is a completely new way of encrypting and encoding light waves so that you don't have this problem of intercept via scatter. So these are kind of exciting examples. IoT based, of course, Myriota Fleet in South Australia being IoT pioneers globally. And so doing things again with ground-based systems that rely on space assets as an example, and helping our utilities to understand how to better use IoT in remote areas. A no-brainer for Australia. And of course, as we talked about before, real-time fire analytics. We've got some really interesting companies in Australia, like Fireball International, already doing work in California, and now looking to do the same in Australia. And we've got massive scale problems, huge land areas. And of course, fresh in everybody's minds is we never want to repeat Christmas 2019, where, you know, I remember being down at Bondi Beach and the sky was orange, dark orange, and later that day, I think it was almost night. So these are things that, again, no brainer. How can we do more real-time fire surveillance and integrating in all these different projects? And then the latest that's happening right now, and in fact this afternoon we're in a big review of all the different proposals, is the UK-Australia Space Bridge. We launched an expression of interest in August. We've had 45 projects submitted in that time. Very, very, you know, quite amazing across these 4 areas how fast that took place. And how quick that was, and how many organizations in the UK and Australia partnered up in such a short period of time. So that was a really amazing experiment that took place. We were, you know, we're quite fascinated by the potential of that entire dimension of Earth, of UK and Australia collaborating, and we're hoping to grow that and make it bigger and bigger and bigger. So, and that's SmartSat. And then I wanted to, if I may, with Eva's permission, I was going to show a little bit about the Waratah Seed project, which is pretty exciting. So I'm gonna stop sharing that screen, and I'm gonna share a little bit about Waratah Seed. Now, I'm gonna share our deck here. Excuse me while I futz around with my screen. And share a little bit about this. So this is an exciting, one of the exciting programs that's happening in New South Wales. And now there's 4 pillars to the New South Wales strategy. One I've talked a little bit about, the SmartSat New South Wales Node. Another one I've mentioned is the Space Research Network. And hopefully you'll be able to get Stefan and Rob to come and give you a presentation on that. The third one that I talked a little bit about is the National Space Startups Hub. That has not yet been sort of, you know, there hasn't been a lot of material created around that yet. So again, I think Sally Ann and potentially myself would love to come back and brief you on the National Space Startups Hub down in Cicada, which is a pretty exciting program. And of course, I'll say in parallel, the Wolfpack Space Accelerator that Jason Held set up with Andreas Antoniadis and Peter Fritz, they've also got funded. So even though that's not New South Wales government program, that's another wonderful thing we have here, which is an accelerator for early stage space startups that's been funded by the Commonwealth. So that's a fifth thing. And then the fourth thing that I was going to show you is this. This is a mock-up. This is not how this is going to look, but this is the Waratah Seed mission, flight qualification mission, and this is the first of its kind in Australia, effectively to be specifically focused on New South Wales space flight qualification. Massive kudos to Professor Eva Cairns, who led the team, who won this bid. Rightly humble, but I think he definitely could brag. And so I'll just walk through a little bit about it. Fundamentally, it's about getting things that are in the breadboard stage, things that are at the idea stage, the electronic stage, and getting them flown. So lift them from TRLs as low as 3 or 4 and getting them up into space. It's an Australian-built 6U satellite running on the quaver bus. So you talked about quaver 1 before, the same bus that's about to be powering the spacecraft that's going to be deployed from the ISS is going to power this 6U spacecraft bus. Lots of writing here, but I'll just highlight that this is essentially this little bit here. Whoops. It's a competition for space startup teams to demonstrate new technologies in space. So in other words, people right now are pitching to get subsidized flight for their payloads. And it's also a rideshare flight for commercial customers. So there's 2 types of payload that we're expecting to see. And these folks have all got together. Quaver, of course, I mentioned Sabre Astronautics, who are bringing in the Australian mission control in Adelaide. They're bringing that capability of that to bear. The wonderful team at Macquarie, University of Sydney, of course, the University of New South Wales, UTS is in this program. So we've got some great, Sydney-based universities, and Delta V, the original, all the founders of Delta V are involved in this project. And so I'm very delighted to be involved. Just to visualize, this is a deck for sponsors. So I'm sure a bunch of this is old hat. What is a CubeSat satellite? You all know. What is a 1U size? You'd all know that. But fundamentally, this picture here, we have the satellite subsystems, roughly 1.5U reserved for the avionics and other subsystems, 1.5U reserved for these competition payloads, which we're expecting to be a quarter U, which is 10 centimeters by, I think it's 10 centimeters by 5 by 5. It's sort of like a long tube, I believe. Or you can imagine the rough size of a PC board, if you like, a graphics card, but square. And then 3U of commercial payloads. And last call, I think it was 65,000 plus GST per quarter U was our price point, and that includes the baseline launch, test, certification underneath the Australian licensing regime for flight, and then in-orbit operations. If you want extra stuff, extra things that required from the spacecraft bus itself, or if you want an extra cutout from the spacecraft for a different type of camera, or a different kind of antenna, or any other, well, you talk to the team, you talk to Ivor and the engineering team, and there may be an extra cost, but 65 plus GST. We have a partnership and sponsorship option, which we're starting to take around corporates. I'd say we're through the initial kind of engagement, so we're going to start ramping this up now that our contract with New South Wales government is signed, and support for different components of the mission you'll see there. And as I said, we've got priceless spaceflight heritage. June Wayne there from the AXA team, also part of this team. We've got the Australian Mission Control Centre, a visual of the actual centre there in Adelaide. We've got the kinds of people that we've had here in Sydney. This was shot in Darling Harbour, one of the SIAA workshops we did a few years ago. Many of the folks there you would recognise. And we have this amazing opportunity as part of this project to do outreach to STEAM. This is a photograph of a workshop that I ran in St Clair's in 2018 around the New South Wales, the University of New South Wales flash field, where we took school students through a simulated Mars and or Moon rover planning mission. That, what happens when you do space? As a consequence just of that workshop that we ran over a 2-hour period in that school, they completely redesigned their entire Year 7 science curriculum. And now every student that goes to St Clair's does a space-centric science curriculum, because it integrates all of the different elements. So if you want to find out more, including geek out on all of the different documents that Ivor and his team, Ivor Kens and his team have prepared for around the spacecraft, go to that waratah or waratah.space or waratahc.space, either will do, and you'll land in the quaver website, and you can go and dig into the different documents and so forth that are there around the mission. And right now we're on track to launch that spacecraft December 2022, if I'm not mistaken. And so we're going to be telling stories about the payloads, about the different milestones along the way. We're going to have sponsors come on board. They're also going to do some work. And then what you'll see these 5 components, the 4 New South Wales government funded ones I mentioned before, the SmartSat Node, the Space Research Network, the National Space Startups Hub, and the Waratah Seed Mission, those 4 New South Wales ones, plus the Wolfpack Space Hub, of course, that is centered around the amazing Sabre astronautics crew. You're going to see those start to work together here in New South Wales. And we want to open up much more regional engagement. So I'm going to be doing a virtual site visit to the University of Wollongong, where there's some extraordinary tech waiting for you to discover, as well as, of course, up into the RFF hubs and other deep tech hubs up in Newcastle. We've got some incredible ag tech stuff going on in Armidale, around the University of New England and other places, and it goes on. There's so much happening in New South Wales, and space finds its way into all sorts of interesting areas around, and I expect to hear more. Wayne, I think that's enough from me. How was that? Was that okay?
Excellent, Tim. We'll open the floor to some questions. I think there was some coming up, but I have been making some comments all based on some ideas you've been giving for speakers. So well, thanks for, can you guys just start typing in some questions down for Tim? Or else we might have a couple of verbals as well. We'll have to unmute, but we might do the, I'll have to look through the chat.
Janine Kitson, thank you for that little, I'll take note of that company in Blacktown. Interesting.
Paul's asked a general question on manufacturing, but I'm not sure if anybody's got the answer for it.
Okay, Paul. Yeah, so in fact, I can tell you that there's a couple of pretty exciting modern manufacturing initiative bids going on right now in New South Wales. And it's very much around how we set New South Wales up as a manufacturing hub for small satellites, as in sub 250 kilogram or 250 kilogram and below scale spacecraft. So definitely yes to manufacturing in New South Wales. Wow, amazing to launch from South Australia, amazing to launch from Northern Territory, and potentially even, of course, launch with Adam and his wonderful crew from Queensland or wherever. I also note there's a WA company that wants to do air launch. So hopefully we're going to have lots of opportunities. And of course, TI Space, not just Gilmore as a launch company, but TI Space, the Taiwanese guys, Hal Chang and his crew are very keen to set up in Australia. And so, gee, we may be experiencing a surfeit of riches in terms of capability.
Hello, sorry, this is Paul here. Can you hear me?
Hi, Paul.
Yeah, sorry, was that my question that you're responding to?
I think so. I mean, the capability to simulate hardware components, test systems, missions. So simulation, yes.
Yeah, that's really what I was about, was the actual
Okay.
simulation capability and the simulation backbone, whether there's any commonality in simulations or whether everybody just goes off and does their own thing and reinvents the wheel, as it were.
Look, honestly, it has been very much like that. And now what we're starting to see in initiatives to do flat sats. One of the programs we haven't yet announced, but we're about to announce from Aurora, the Space Startups Cluster, is a thing called the Aurora Distributed Flat Sat, exactly for this. And in fact, what it is it's a satellite bus that you can connect to remotely to test interfaces, to test the software integration component, and even some of the hardware integration components that a payload might have with a satellite bus. And the larger intent there is to do exactly what you just said, which is to try to Legoize it, right? Make it more plug and play. I'll also say there's a fascinating company that has one of its co-founders in Sydney. They're called Astera. I'll drop a URL for them in the chat here. And Astera is founded by a couple of ex-Planet vice presidents. So Planet, you may recall, was originally started by an Australian guy, Chris Bazushin, ex-JPL. So they went on to do a rule. They had a rule in Planet, which was no space qualified hardware on board, all COT spacecraft. And so these guys who started Astera want to do an open source satellite OS and abstract out a huge amount of the different bespoke components into a software layer. Effectively like a red hat for satellites. And the reason they're very credible, they're, as I said, they're ex-Planet guys. And I think they've been able to almost close a multi-million-dollar seed round in a matter of, less than a month, because they have this sort of great credibility in Silicon Valley, great credibility in the Indian ecosystem. And of course, one of the co-founders happens to be here in Sydney, decided to move here. So exciting stuff in the ecosystem, exactly to that point, Paul. And I think,
thank you.
Yeah, great question.
Janine's made some comments about Starlink and constellations. Yes, that's possibly a little bit far away. But it sounds like there's a couple of different projects potentially that could turn into it, Tim.
I think if you think about Starlink is a little bit like the Apple iOS, right? So who's going to do the Android version of Starlink? Yeah, where it's an open network with a set of standards that allow you to sustain that very, very low latency, high throughput, universal availability thing. Starlink, Apple, of course, the richest company in the world now, thanks to their first mover advantage around iOS and their app store. So Elon definitely in good company with Starlink, although we are seeing a lot of capacity in the market. So the price is going to fall for that ubiquitous communication, and that's going to cause some companies to need to merge or going to need to consolidate. So we'll see all sorts of interesting shakeout. I think for Australia, we're definitely interested in working with other countries to provide that ubiquitous comms. So we're maybe not dependent on someone like Starlink. So we have the ability to do our own backup. But yeah, that's right. And I think it's going to be not going to be either or. Janine, not going to be either or. I think we're going to see an and scenario where instead of sort of saying, okay, well, it's terrestrial 4G or satellite 5G, I think we're going to see these things become an and we're in the messy middle now of this sort of transformation. Let's see where it goes. It's going to be quite fascinating. So some other great questions, which I'll have a go at answering. Some of these will definitely be in my opinion. So I think that we are, 3 years, little over 3 years into our space agency journey. And our space agency isn't really, right, a proper, full space agency in many ways. It's still a department, a sub-department of the Department of Industry. And so theoretically, a minister or a cabinet can come along and decide to delete it, right? So what we in the Space Industry Association of Australia are now calling for is a more guaranteed funding regime and some other kind of governance model, whether it's a statutory body or something else that might be appropriate. So it has immortality and it can really play a better leadership role and stand on its own 2 feet and not necessarily have to run the gamut of Department of Industry rules around procurement and so forth. So they've done really, really well, but we've accepted the branding tension implied in an Australian Space Agency, but really it's more of an Australian Space Office plus. So things like the international collaboration you're calling for, partnering with ESA and International Space Station, well, it turns out we have incredibly deep personal links into all those networks. We just haven't formalized and put money behind those things yet. Also, I will say that some of those ecosystems are very intrigued by the potential we have in Australia to reinvent what a space agency is and reinvent what space asset commercialization might look like. So I think there's a watch this space aspect to what's going to happen over the next 18 months, 2 years as we come out of COVID. And I don't think you'd be the first person, John August, to be like, wow, how might we get involved in some of the amazing activities going on in the UK? How might we leverage our incredible relationships with Japan and New Zealand and other ecosystems where, there's a lot of capacity building going on. But we also want to I do think we want to stop being a freeloader when it comes to in-space assets. And we want to start to participate as more of an equal partner. Julian, I don't know enough about your question about heavy ion sources, but I will say that ANSTO here in Sydney does do radiation hardness testing. I also know that ANU has been able to utilize very high-powered lasers to do simulated radiation testing on electronics with, to a very high degree of accuracy and as an analog to that. But heavy ions, I'm not sure. There is one of the companies that are a member of the Aurora space cluster, which is developing a beta particle RTG, radiothermal generator, Those guys are interested in flying their beta particle generators, like 20 years of power in this sort of sealed device. And heavy ions, I think, a lot less dangerous than traditional RTGs is their idea, so we'll see. But if you're interested in an introduction to those guys, I'd be happy to connect you, and I'm sure they'd be fascinated by anyone's interests. Alan's asked a question: how far do you think we are from a launch facility? What are the barriers? Well, as I think Kerry mentioned before, we have a launch facility down at Whalers Way now, which is fully approved and accredited, and is now they're now expanding their envelope of operations, and that's specifically perfect for sun synchronous launches south. So few flights intersecting that, so it's pretty exciting. And their first customer, bam, Taiwan, down there like a shot, because launching satellites from Taiwan, very difficult, dangerous, and potentially geo-destabilizing. So Whalers Way, that's our first one. I know Equatorial Launch has gone a long way down the path of getting their facility up and running. I'm hoping that the example that Lloyd and his team at Southern Launch has been able to set will make it easier for the space agents and everyone else to get Kylie and her team at Equatorial Launch through. And then let's see how the guys go in Queensland. 2 efforts in Queensland, in fact, to do launch sites. The barriers are definitely around safety and accreditation and maximum probable loss calculations and all sorts of other things, insurance, you name it.
Yeah, 3 possible sites in the next 5 years, Tim. I know that more Space is trying to do something about the Abbotts Point area.
Abbotts Point, that's right. That's the one, yeah.
And that was the other one. The Queensland government's starting to finally get interested in that. And as I said, the Northern Territory one's been going for a while now. So we could end up with 3 possible sites, and they've all got slightly different payload capabilities, which is the interesting thing about it all, really.
Yeah, that's right. It's actually pretty amazing because there's very, very few, a handful of private space launch facilities in the world. So we've kind of gone from the back of the pack to the front of the pack with Southern Launch's efforts there. So it's pretty exciting. There's one in Alaska, there's one in Norway. I think there's of course a couple in the US. That's about it, right? So it's pretty interesting. Kerry, maybe an interesting question to dig into. Are we the 5th private launch or 4th or 5th private launch facility in the world? Well, that would be getting us right back up to the front of the pack.
Jaden's got a question here, I see, on funding.
So Jaden, so one of the other roles that I've taken on recently, to get myself out of other industries and focus on space, I've taken on a role as representative director for Euroconsult in Australia. And Euroconsult's kind of like one of the world's top space intelligence and consulting firms. And I've been pretty blown away by one of the bits of intel that I'm allowed to share around space exploration. So over the next 7-8 years, the space exploration industry, it's currently around $17 billion of government spend a year, and mostly on big programs. But it's being unbundled. And that $17 billion spend is being spent more and more and more on SMEs and young companies. But not only that, it's set to grow 3x between now and 2030. It's set to grow from around 17 billion a year, as I said, to around $54 billion a year globally. And that's also what people are characterizing as space exploration. They're starting to shade over into the in-space economy, right? Like gas stations in orbit, servicing of all these thousands of spacecraft. Somebody mentioned the other day, 33% of all spacecraft ever launched have been launched in the last 18 months. And we're going to see that pace accelerate. And these spacecraft, of course, are shorter lifetime, and increasingly they're being built to being refueled or serviced or upgraded in situ in space. So the space exploration realm is going to grow 3x. And I think also this whole realm around, that people have been inspired by the moon and cislunar domain is seen now as a domain of contention between different nations. So there's a bit of a new space race going on between China, Russia, and the rest of the world. And so I think what we're going to start seeing is some of those returns are going to start to crystallize around quantum comms encryption, around more resilient space systems, around human systems. Artemis is quite interesting. I don't think a lot of people have cottoned on that it is actually a space station in orbit around the moon. And, you know, if you're in the ISS and you need to get back to Earth, well, you jump in your Soyuz capsule or one of your SpaceX capsules, and, you know, maybe a day, half a day, you've splashed down somewhere safe. If you're in orbit around the moon, you're probably a week away from getting back to the Earth in one piece. It's an order of magnitude tougher challenge. And so with that, I think we're going to start seeing a completely new realm of human systems, life support systems, biophysical systems, even things around psychology, creativity, expression. I think we're going to see an incredible new range of things going on. And to have somebody that far away, that isolated for that length of time, it blew everybody's minds apparently back in the era of Apollo 8, the first vehicle that did actually transit from low Earth orbit with human beings aboard and go around the dark side of the moon. Nobody knew if they were going to re-emerge from the dark side of the moon in the first transit. And they had to do a retrograde burn to go into orbit around the moon. Were they going to crash? Were they going to screw the burn up and disappear into, you know, effectively not disappear, like die slowly as they drifted out into deep space and run out of air and water? So Artemis is a pretty intense effort. And I think when you start thinking about human factors, I think the public might start engaging around that. Certainly the first woman on the moon and the next man on the moon, that's an exciting story right there. And I think they will definitely capture the public's interest if we get that messaging right. Anyway, that was a long answer. That was a rant.